Hello friends, so to the question, find the mass m of the hanging block in the figure which will prevent the smaller block of mass small m from slipping over the triangle block of mass m prime. All the surfaces are frictionless and the string and the pulleys are light. So this is the mass which is hanging. We are supposed to find out this value, and this is a triangle of mass m prime and this is block m, and it is said that it should not be slipping. So for this small block of mass m, if it's supposed not to be slipping, then there should be some balance of the force which should be prevented it from slipping. So in this case, if you draw the free body diagram for this mass m, free body diagram for block m, so let us suppose this is the block m. Okay. Sorry, it will be in this direction. Let me draw it here. So this is block m, and there will be a force, or rather we can say mg, that will be acting downward, and we have this angle that is given as theta. So the mg can be divided into two components. This angle will be theta, so we are going to have this as mg cos theta, and this will be mg sin theta, and a pseudo force because of the movement. If it is moving towards entire system, this block m is moving in downward direction, so this combined system will be moving toward the right. We can say that there will be a pseudo force which will be acting, and its value will be equal to ma, where a is the acceleration, and for this also. Now this ma can also be divided into two components. Okay, so one will be in this direction, another one will be here. So we get this as ma cos of theta, and this will be ma sin of theta, and there will be also normal. Let us suppose this is n1 which will be acting on the block. So these are the various forces. Now we are not going to consider the forces which are not contributing the motion, like n1, ma sin theta, mg cos theta. They are not having any contribution to the motion. So motion of this block m is only being affected or dominated by two components. One is mg sin theta and another one is ma cos theta, and it is given that there should be no slipping. Okay, so it mentioned for no slipping of block having mass small m, this mg sin theta should be equal to ma cos theta. So this mass cancels out. From here we can find out that a is equal to g tangent of theta. So this is basically the constraint relationship between the m and m prime. Okay. Now for free body diagram for block of mass capital M. This is our mass capital M, and there will be mg in the downward direction, and we have T tension in the upward direction, okay. And there will be acceleration A also in downward direction. So we can say that mg minus T will be equal to ma. From here we can find out T. We can use later on also. Let us call this as equation number 1 and this as equation number 2. Now we can consider that M prime and M are a single block. Okay. If we consider this single block, considering M and M prime as a single block of mass M plus M prime. So let us draw the single block like this. This is our M plus M prime, and there will be tension T, and it will be moving towards the right with the acceleration of A. So you can say that our tension T is equal to M plus M prime into A. Let us call the equation number 3. So using equation 3 in equation 2, so we can say using equation 3 in equation 2, we get mg minus M plus M prime A is equal to ma. And we also know that value of A is g tan theta. So you can say that using equation 1, we get mg minus M plus M prime is g tan theta is equal to M g tan theta. So we can cancel g from the entire equation. Okay, so let me write this equation again. Here we get M minus M plus M prime tangent of theta is equal to M tan theta. So this can be further written as, taking this M into 1, so we get M 1 minus tangent of theta is equal to M plus M prime tangent theta. For the solution will be M is equal to M plus M prime, and this is equal to tangent of theta divided by 1 minus tangent of theta. Now we can divide and multiply numerator and denominator by tangent of theta. So we can say that M is equal to M plus M prime divided by or rather we can say if we take tangent theta common from the denominator, so this will be 1 upon tangent theta, so this will be giving us cot of theta minus 1. So this is the mass of the, so this was the mass m of the hanging block such that there is no slipping of block having mass small m. Thank you.